how every stakeholder in industry is associated to factory automation, and why it is important for you to learn the shop floor concepts or the concepts at the line of a particular industry, even if you are going to be recruited for industry 4, because you are going into transformation from industry 3 to industry 4. You need the basic concepts of industry 3 also, which is very important. Okay, so few of you were having some queries regarding the current and voltage of sensor. So now anyone has an answer that why only 4 to 20 milliampere current is passed through sensor? Any answer? I'll just give you a very partial answer to it. We will cover the entire session for that, but it is just for your interest. Why we are the only single part of question I am going to attend. Why we are just using 4 to 20 milliampere? Why not 0 to 20 milliampere? Any fluke for that question? Are made of BJT? Yes, bijunctional transistor, which is current control device. Yes, Shubham, you are correct. But why 4 to 20 milliampere? Why not 0 to 20 milliampere? Why it had started from 4 to 20 milliampere? Yes, Shubham, very correct. Is in cutoff region. So what is cutoff region? See, a sensor is going to give you a particular output. Okay. So for example, if a flow is going to be calculated, okay. So if you are calibrating that 0 milliampere is for 0 level, and for say 20 milliampere there is a 20 level. Okay. So in the chat box I am also writing it at 0 milliampere. 0 milliampere is 0 level, okay, and 20 milliampere is 20, say 20 centimeter level. Okay, so we have made a sensor Uh, Students, am I audible now? Hello, students. Yeah, there was a network issue. I think the LAN network was not working. Okay, no issues. So my question was that let us repeat that particular question. That if we are making a particular sensor which gives 0 milliampere for 0 volt and 20 milliampere for not volts for 20 centimeter. Okay, there is a level sensor which has this kind of calibration. So what will be the signal when there is 10 centimeter level? What will be the signal? Assuming that it is a linear sensor, the relationship is linear. Class, please answer. Yes, correct. Others, please respond to this question. 10 milliampere. Okay. Okay. I completely understand that this question is very easy, but until and unless you will not reply in your own mind about this particular question, you will not be able to understand that why we are using 4 to 20 milliampere. Okay. So now if the level is 2 centimeter, now if the level is 2 centimeter, okay, and the sensor is linear in relationship, what will be the current pass through sensor to the PLC? We have calibrated it from if it is 0, then it is 0, and if it is 10, then it is 10. So it will be 2 milliampere, right? It has a linear relationship. We have calibrated it in such a manner. Okay. Now, just suppose that your minimum level is for the least level will be for 0. Am I correct or not? Your least level is for 0. So there will be no ampere traveling from your sensor to your PLC. Okay. So 0 will be the condition of 0 level and 0 will be the condition for 0 level and cutoff. Yes. For cutoff wire, or you can say failure of wire, for any kind of failure. Okay, so now how will you bifurcate that? How are you going to bifurcate that? That if this calibrated sensor is showing you 0 milliampere, then it might be that the level is 0, and there might be that there is a cutoff or a failure. Okay, for the similar reason, we normally use the range of 4 milliampere to 20 milliampere. Why? Because now the least level, at the least level, at the 0 level, the amperage that will be transferred will be 4 milliampere. Okay, and now for say 10 mm, 10 centimeter of you can say level, the reading is 10. Okay, so please listen to this question very carefully. If there is 0 level, then the milliampere that will be going will be 4. Okay, and if the level is 10, then your milliampere is 20. Now tell me, if the level is 5, what will be the amperage that the sensor will pass? You understood the question, right? You need to procrastinate on your own. You need to look for the answers on your own. It is very important because it is very important for your understanding. Whether it is robotics, whether it is mechatronics or any kind of factory automation, your thinking capability is very much necessary. 12. Okay. Yes, 12 million. Now, my question is that if there is a cutoff, then what will be the amperage now? If there is a cutoff, what will be the amperage? No, the wire is break. I'm not talking about zero level. I'm talking about that there is a failure. That sensor is not working. The wire that was connected to the sensor is break. Yes, the answer is zero. Now you know that for low level, for zero level, your amperage will be 4. But if there is a wire break, then your amperage will be 0. Okay, so now you can bifurcate the signal according to the amperage. Meanwhile, in the first case where you have calibrated from 0 to 10, there you were not able to bifurcate that whether the 0 is for wire break or 0 level. Therefore, we take a minimum level of amperage 4 milliampere just to avoid the noises also. Okay, so that we can bifurcate from failure. Okay, and this is just a single part of your question, that why 4 to 20 milliampere, why not 0 to 20 milliampere? We have lots of question in this single statement only. Why only in milliamperes? Why only current? Okay, few of you know the answers also, but there can be many questions that can be generated from this single question. Okay, and if you are comfortable while answering these questions, you are going to be very much comfortable in industries also. Okay, it actually happens. Uh, with my personal experience, I can say that we don't look into the very basic specifications of any component. Even if I am from mechanical background, मैं तब भी if I will be going to mount a say gearbox, so I will not look at the specifications of say flange, and if flange is not working correctly, is not of correct dimension, even if the power and the torque is same, all the bookish or the all the you can say specifications are same. Even if a single you can say mechanical screw or thread is not matching, then it is of no use. Okay, and for electronics, what is important? If you are an electronic engineer, what will you look? For example, if you want to buy a motor for a conveyor system, as an electronic engineer, what will you look into that? Suppose you are a assistant manager as an electronic in electronic department. We have separate departments. Electronics is separate. In Indian industries in particular, it is a very, I don't know why this culture has been prevailed, but we are still improving to integrate all the branches. But still till now, mechanical is a separate branch, electrical is a separate branch, and electronics is a separate branch in the production line itself. So tell me, as an electronic engineer, what will you look if you want to procure a motor for a conveyor system? Answer please. Brush or brushless? Okay, good, Ritik. That might be correct. Okay, students, uh, do you know what is IP rating for a component? What is IP rating for a component? Okay, you don't know what is IP rating. Okay, okay, okay. Every component, every component has a particular IP rating, and that full form of IP is Ingress Protocol. Okay, so the full form is Ingress Protocol. We will have a session for that also. Okay, but it is just to let you know that what kind of specifications can be required. And at this point of time, I'm just going to tell you the basic of what IP is. It is Ingress Protocol. It depends on the ruggedness of the system. That means that at what level it can sustain the harshness. So in industrial environment, your component, say PLC or your any component, will be susceptible to harsh environment. Am I correct or not? So what kind of harsh environment are there in industry? There will be dust, there will be moisture, there will be temperature, there will be wind. Okay, so main component of ingress protocol is about the solid particles and about the liquid particles. That how it manages the solid particles and how it manages the liquid particle, how it protects itself from the kind of solid particles or liquid particles. Okay, we will have these kind of quick sessions, and we will also complete these concepts. The reason that I asked these questions are is because just to create an interest in you, that what kind of questions are asked when you are in industry, rather than what you are getting in academics. Yes, academics concepts are important, but these questions, if you know the answer of these questions, you are going to gain a lot of things through that. Okay, so now let us continue with our slide. uh, yeah, we were on this particular slide, and I need answer from your side. Let me present now. Is my screen visible, guys? Yes. Okay, what you need to do is you need to make the energy flow diagram for this particular system. Okay, so first of all, I told you earlier that how the energy will flow. We will look into the answer also, but I need answer from your side. You all are connected through WhatsApp in the internship automation group. All of you are there. Okay, so first of all, you will make the energy flow diagram for pneumatic system. You know that for pneumatic system, what there was a directional control valve from where air supply was going, and it was changing the direction, and there were two sensors which were providing the signal that how what position your spool, or you can say the piston inside your cylinder is. We have already drawn this yesterday. Now you just understand, introspect by your own, whether it is wrong, whether it is right, it doesn't matter, but it is important for you to practice this. Once you know that how a system works, how energy flow works, you will be very much comfortable with all kind of processes. Okay, so it is very important for you to introspect. Now I need answers for only pneumatic cylinder on WhatsApp group. Okay, you take your time and you respond for pneumatic cylinder. If you have completed pneumatic cylinder and you have time, you complete it for thread, for DC motor, for this gear sensor. This is just a lifting device which has two sensors, okay, which will give information, and DC will give a motion through thread. Okay, there is a chute where the material will move. Again, your material is only gear here. Okay, the air that is passing is giving you energy. Okay, and what were our what we say, we have taken some constraint that rules that our information flow will be of dashed line. Okay, our energy flow will be of solid line single, and our material flow will be of double line. Okay, this was our rule. So by following this rule, start with pneumatic cylinder. I need answers from everyone on the WhatsApp group. Okay, and this practice is very much important because the more and more you are compatible with the process line, the more and more you will be compatible with the integration and about all the aspects of integration of a system. Okay, so you take your time. We have to complete this exercise. If there is any query, you can ask on WhatsApp. Okay, for your reference only, I am also giving this question on WhatsApp, and this will be your assignment. Okay, if you are able to complete it in the class only, that will be good for you because this is going to be your assignment also. You have to submit this. Now you have on your WhatsApp group also. I need answer only for pneumatic system if possible. If you have completed pneumatic, then how your other system, just like gear lifting system, your DC motor system, how it is connected. Okay, so Ritik had answered the question. Very correct, very correct. Just Ritik, add the kind of energy that has been given to solenoid. And we talked about sensor also. That this is a magnetic reed switch. It is going to get information. It is going to pass information, but it will be fed with. We covered it yesterday, right, Ritik?
Yes, sir.
Okay, this was your collector.
PNP sensor 24 volt was the input.
You have to give a supply
24
also.
volt input.
You have to give a supply also, right? There will be a continuous supply to sensor. Okay, it will be a 3 wire. I already told you that it will be a 3 wire component. Okay, so from one side it will get continuous 24 volt, one will be ground and one will be output, and that will depend on the external environment. Am I correct or not?
Yes, sir.
Okay, so just keep that in mind. Bhanu, you missed sensors. Where are these sensors? What are the role of these particular sensors? Although most of the part is correct. Very good, Ritik. Very good, Bhanu. And try to answer on your own. Okay. If you will just look into the answer, you are not going to get comfortable with the next sessions, because once you get to know that how the process is, hmm, Sahil, in some sense, you are correct. Yes. Ankush Singh, yes, you are also correct. Um, Partially correct. So how many answers? One, two, three, four, five, six, seven, eight. Shubham, Nandini. So most of you understood that what it is. This there is just a single issue that has been repetitively not addressed by most of the students. And for that, I think we should proceed with a video, because sometimes visuals are much more uh, informative than audio. So let me just look into the solution for your, because most of you have not addressed electrical energy will be provided to sensor. Most of you have drawn it correct. Most of the part is correct. That from PLC there will be an information to solenoid, and sensor there will be two. From cylinder there will be information to the sensor. There will be no energy to the sensor. There will be information to the sensor. Okay. Yes, for solenoid, what kind of energy will be there? For cylinder, one of you have made Alok had made. For cylinder there is a solid line also, and there is a dashed line also. What kind of flow will cylinder provide to sensor? Whether it will be information or whether it will be energy, it will be information. Energy to sensor is getting from outside. Okay. So before telling you about the real pass, it is very important for you to understand this kind of wiring. Okay. Just look at these videos. There are two videos. Just have a look at them.
Easy to manage. Let's look at how business hosting is a simple yet powerful solution.
Are connected to actual DC sensor, like a switch or a contact to a PLC input card. You'll also learn what a two-wire discrete sensor is and recognize some of the common types of two-wire discrete sensors.
So you have two wire sensors and you have three wire sensors. Your magnetic reed switch was of 3 wire.
If you enjoyed these videos, be sure to click like and subscribe so you never miss a new one.
So is the video audible, class? Is the video? Sir, please repeat the question. Okay. What question? At what time? 2:29. Oh, sorry, I was not addressing that. Okay. So let us continue with this video. So class, in addition to our class, what I am going to do is I am making a Word file for all the videos that I will be showing, because like this, okay? And I will share this document with you all, okay, at the end of the program. What it will do is that you will have a very specific, you can say, document, that if you have confusion regarding anything, you can just look into this. You need not to search for the specific thing, because even searching now, nowadays for a particular concept is an art. Okay, so what I have done is that the most important videos that are related to this session, I have made a document for that, and I will just share it with you. Okay, will that work for you? Kindly respond. Okay, and you can also add on into this that you want this kind of video, you want this kind of information. Okay, so what will happen in the end of session, you will know that from which line we were going, and if you have any doubt you can get from that. Okay, so that will be a very good learning path.
DC sensors can be used to indicate the state of a device or a process to the PLC program. Knowing these input states can allow the PLC program to make decisions, such as when to start or stop a pump. In this diagram, the programmable logic controller, or PLC, is running a ladder logic program. The push button is connected to a PLC input card, and the logic program is written to sense the state of the push button. When the push button is not pressed, the logic does not turn the pump on. Now, if the push button is depressed, the PLC ladder logic program will sense that the push button has been pressed and will start the pump. So, let's see how we can make this important input information available to a PLC program. In order to do this, we need to understand more about these discrete sensors and how they're wired to the PLC. Discrete DC sensors, or discrete direct current sensors, operate in a circuit with a battery or other power source, commonly known as a power supply. A power supply is placed in an electrical circuit to provide power to the connected devices, like a switch or a lamp. DC power supplies are referred to by their voltage and capacity, indicated by how many amperes they can supply. The more amperes a power supply can deliver, the larger and more expensive they generally are. In DC PLC circuits, the power supply almost always supplies 24 volts DC to the connected devices. In this diagram, a DC circuit is shown, which turns on a lamp when a push button is pressed. The common trait of all discrete DC sensors is that they have exactly two operating states, on and off. A discrete DC push button, as in this diagram, is on when it is pressed and its internal contact is closed, forming a complete circuit and allowing the flow of electrons. When the push button is released, its contacts are opened again, the circuit is broken, and the flow of electrons stops. The state of the push button is off. Other common examples of discrete DC sensors include proximity switches, selector switches, and photoelectric sensors. If we want to monitor the state of the push button in the PLC, we would need to connect the two wires of the push button to a digital input card in the PLC. When the push button is not pressed, the PLC would see the input state as off, or as a 0. The circuit to or from the PLC input is open or not energized. When the button is pressed, the PLC input senses the change in push button state and transmits this data through a communication channel to the processor memory, or data table. When the push button is pressed, the circuit to and from the PLC input is closed, or energized. We could then write a PLC program, which resides in the memory of the PLC, to take some action, like turning on a lamp or a pump, when the push button is pressed. Wiring a discrete DC sensor to a PLC input card is easy and straightforward. In this video, we will consider only the
Class, just focus on this. This is a 2-wire sensor. Okay, this is not a single wire sensor. Okay, just focus on this.
devices that have two wires that need to be connected to the PLC digital input card. An example, a Hall effect proximity switch, is shown here. In a separate video, we will consider more complex 3-wire devices. For most PLCs, the input cards must match the type of circuit that will be employed to interface the device to the PLC. For example, a discrete DC device must be wired to a discrete DC input card. A discrete AC device would require a discrete AC input card. In this video, we will only consider DC devices. In order to connect a 2-wire discrete DC device to the PLC, we will need to identify whether the device is polarized or non-polarized. For a polarized device, the 2 wires will be labeled. One wire is labeled positive, and one wire is labeled negative. In this simplified diagram of a photoelectric switch, the positive wire must be connected to the positive terminal of the PLC input, and the negative wire must be connected to the negative terminal of the PLC input. If this convention is not followed, the device will not indicate correctly in the PLC, and the device may be damaged. For this photoelectric switch, reversing the positive and negative wires will damage the phototransistor, and there will be no power to the transmitter. The switch will not function as intended. For non-polarized devices, like simple push buttons and selector switches, the device may be wired with either wire connected to the positive terminal of the PLC card and the other wire connected to the negative terminal of the PLC card. In this example, the proximity switch is a non-polarized device. It has 2 wires, a white wire and a black wire. On the left, the white wire is connected to the positive terminal of the digital input channel, and the black wire is connected to the negative terminal. Because the device is non-polarized, the wires could be connected in the opposite configuration and still provide the correct indication of its state in the PLC. This is depicted in the drawing on the right. Now, let's see how 2-wire discrete DC sensors are connected to actual PLC I/O cards. This is a schematic of a Siemens SM321 digital input card, part number 6ES7321-7BH01-OABO. It is a 16-channel, 24-volt DC digital input card that is.
So students, don't get focused about the nomenclature, okay? The nomenclature of PLC, about the input card, about the output, about the IO port, that we will cover, okay, in PLC part. We need not to get worried about it. Just focus on the type of sensor and how it is getting integrated to a PLC. That's it. Okay. It is very important because all of you have made a very common mistake by not giving a electrical supply to a sensor. Although at the very first session, I told you that those reed switches are PNP type switches. Okay. So it will be very useful for you to understand that concept.
Very popular in Siemens PCS7 and S7300 PLC systems. This digital input card wiring scheme is similar to most digital input cards used in the process industries. The SM321 has 20 screw terminals to which the digital inputs are connected. As we saw previously, for 2-wire discrete DC sensors, each digital input requires the connection of 2 wires. The SM321 card requires 24-volt DC power to perform several functions. First, the card itself requires power to light the status LEDs, perform diagnostics, and to communicate the card's input statuses back to the PLC. Power to the card is supplied by a 24-volt DC power supply connected to terminals 1 and 20. Internally, inside the SM321 card, this same 24-volt DC power is connected to terminals 10 and 11. The power at terminal 10 supplies power for the top group of 8 digital inputs, and the power at terminal 11 supplies power for the bottom group of 8 digital inputs. Let's just focus on the top 8 inputs, labeled as input 0 through input 7. In practice, the PLC input card channel connections, terminals 2 through 9 and 12 through 19, will be brought out to a terminal block. These marshalling connections, as they're called, allow the field wires to be more easily terminated in the control panel. These terminals are represented by the letters A through H in this diagram. The installer usually pre-wires the marshalling terminals, Terminal 2 on the SM321 card to Terminal A, Terminal 3 to Terminal B, A, and so on. Now, let's connect the proximity switch and the photoelectric switch from the previous examples to the SM321 card. The 8 marshalling terminals, A through H, are wired to channels 0 through 7, and are the negative terminals in our discrete circuits. Plus 24 volt DC will be obtained from terminal 10 for the top 8 inputs, wired to the SM321 card, and from terminal 11 for the bottom 8 inputs, wired to the SM321 card. Since the push button is a non-polarized 2-wire discrete device, we can connect either its white or black wire to 24 volts DC, and the opposite wire to terminal A. For a polarized device, like the photoelectric sensor, care must be taken to connect the positive wire, or the red wire, to the 24 volt DC, and the black wire to the negative terminal, or the PLC input card connection. If we connect the photoelectric switch to PLC input channel 3, the red wire will be connected to 24 volt DC, and the black wire will be connected to terminal D. To review, we have learned that there are many types of discrete 2-wire DC sensors that can be wired to a PLC input. Some devices are polarized, and some are non-polarized. For polarized devices, it is important to connect the positive wire to the power, or positive terminal, of the PLC input, and to connect the negative wire, or common, to the negative terminal of the PLC input. For non-polarized devices, either wire can be connected to the positive terminal, with the opposite wire connected to the negative terminal. A schematic of your specific DC digital PLC input card is required to determine how your specific device should be wired. The terminals connected to 24 volts DC are the positive terminals. In this example, the PLC input card terminals are the negative terminals. Make sure that you head over to realpars.com to find even more training material for all of your PLC programming.
So what did you learn from this? I just need few answers from your side. What did you learn from this? This was a 2-wire discrete DC sensor. It can be of 2 types. What were the 2 types? What were the 2 types? Polarized and non-polarized. Yes. So can we, thank you Ritik, thank you Hitesh, Muskan, Kalpana, polarized and non-polarized. Okay. See, it might seem a little bit tough for you at this particular state, but we are going to repeat these things so many times that it will be easy for you at the end of the session. Okay, and during offline session you will be telling me on a single IO board what to connect with what. Okay, so just I'm telling you, giving you an example that how we are going to connect with this. For this we have dedicated IO modules here. Okay, the terminal block that he was telling was this one. Okay, so this is the terminal block, but we have a separate IO block where you have all the wirings. Okay, and now you can see
Also, no sound from your side.
am I audible now, class? Okay. So there was some serious network issue right now. No issues. I'm just going to repeat my question that uh, how many wires are there for a single sensor? This is coming from a sensor. How many wires are there? Is it a 2 wire sensor or a 3 wire sensor? Every kind of wire has a color code associated to it. It is a 3 wire. Please just focus on this image. Okay, let me just. It is a 3 wire sensor, right? So you need to understand that how it is connected to PLC. Okay, so every PLC is connected to a separate IO port, and here and the meaning of IO port is just to make you understand. But whereas there will be different input and output modules, you can't just add all the wires to the PLC. It is very necessary for you in industries that we should have different IO modules also in order to increase the number of connections to a particular PLC. Okay, now you can see 3 color wires. Okay, so what are the 3 different colors? Please answer. I need answer from all of you. I'm just asking about the colors. Black, blue, and brown. Yes. Okay, so see, color coding might change, but the real sense that why there are 3 wires, why 3 wires are connected to it, that is the main issue. Okay, and you need to understand that what is the difference between 2 wire and 3 wire system. Okay, so and why we are connecting and how we are going to connect a 3 wire sensor to a PLC. Okay, so just for enthusiasm, for the sake of enthusiasm, I'm just going to ask that you no need to answer that which color is responding to what, but what will be the 3 kinds of wire here? What will be the 3 kind of wires? Is it electrical supply? Is it ground wire? Or is it something else? Plus, minus, and ground. Yes, plus, minus, and ground. Phase, neutral, and earthing. Anyone else? Two power wires and one load wire. Yes. Yes. Uh, I can say you are near to the answer. One load wire is correct, but are both wires are related to power only? So the answer to this question is that one is of 24 volts, and that 24 volt has been supplied to the sensor. Okay, and if a 24 volt is supplied to the sensor, so there will be one wire that will be passing to the ground. Okay, and the third wire will be your output or the load wire. Okay, so one is your 24 volt, one is your 0 volt, and another one is your output. It can be your output can be 24 volt or can be 0 volt. That depend on that kind of switch that is. Okay, So if it is a PNP type of switch, PNP type of sensor, then your output will be, if it is a PNP type of sensor, then the output will be positive or negative. You know what is collector in PNP sensor? Okay, for PNP sensor there are three parts. What are those three parts? Just tell me. Base, emitter and collector. Okay, हम बेटा बेसिक बहुत पढ़ते हैं कि हमको कहाँ सप्लाई देना है, क्या सप्लाई देना है, कितना करंट कहाँ से पास होगा, किस तरफ से करंट पास होगा, अगर पीएनपी सेंसर है तो कहाँ से पास होगा, लेकिन रेलेवेंस नहीं देखते. ठीक है, ये आपके सारे के सारे जो सेंसर है वो पीएनपी सेंसर ही है, एक टाइप ऑफ बीजेटी ही है. और अगर आप ये देखें, अगर आप इसको इंट्रोस्पेक्ट करें तो क्या हो रहा है इसमें, आपके पास एक 24 वोल्ट है, एक 0 वोल्ट है और एक लोड वायर है जो कि या तो 24 वोल्ट देगा या 0 देगा. ठीक है, अब पीएनपी सेंसर में वो कौन सा पार्ट होता है जिसमें कि हम एक्सटर्नल एजेंट से करंट को पास करा भी सकते हैं और नहीं भी करा सकते हैं. कौन सा पार्ट होता है? बेस होता है, एमिटर होता है या कलेक्टर होता है? थोड़ा सा अगर आप भाषा को भी देखेंगे तो भी आपको समझ में आएगा. बेस है, एक एमिटर है. एमिटर का मतलब क्या हुआ, वो एमिट कर रहा होगा, मतलब वो 24 वोल्ट दे ही रहा होगा हर सिचुएशन में. ठीक है, बेस है वो कलेक्ट कर रहा होगा. ओके, 24 वोल्ट या फिर आप ये कहो कि वो एक कोई ना कोई चीज प्रोवाइड कर ही रहा होगा. और बेस क्या है, वो उस चीज को सोक कर रहा होगा. लेकिन जो आपका कलेक्टर है वो एक्सटर्नल एजेंट्स पे डिपेंड करता है. इसका मतलब जब मैग्नेटिक रीड स्विच में मैग्नेट पास में जा रही थी मैग्नेटिक स्विचेस के, तब एक कनेक्शन बन रहा था. उस कनेक्शन की वजह से करंट कहां से पास हो रहा था? कलेक्टर से. ओके, तो एक मोटी मोटी चीज, अगर आप ना बहुत डीप जाना भी नहीं चाहते हो तो आपको बस एक सिंपल सी चीज याद रखनी है. अगर पीएनपी सेंसर है तो कलेक्टर या फिर आपके लोड से करंट पास होगा, यानी कि कलेक्टर आपको क्या देगा? +24 वोल्ट. और अगर आपका एनपीएन सेंसर है तो वो क्या देगा? ट्रू कंडीशन में एक्सटर्नल एजेंट के उसमें इन्फ्लुएंस में आकर के 0 वोल्ट. तो अगर आपका पीएनपी सेंसर है तो वो 24 वोल्ट देगा और एनपीएन सेंसर है तो वो 0 वोल्ट देगा एक्सटर्नल एजेंट के इन्फ्लुएंस में. नाउ यू ऑल आर अलाइंड. कोई डाउट है तो अभी पूछ लो. बहुत सिंपल सी चीज है. अगर आपको कुछ समझ में नहीं आ रहा हो तब भी आप ये चीज तो याद रखेंगे कि अगर पीएनपी सेंसर है तो कलेक्टर से हमेशा 24 वोल्ट आएगा एक्सटर्नल एजेंट के इन्फ्लुएंस में. मतलब जब मैग्नेटिक रीड स्विच के पास मैग्नेट आएगी, मतलब वो पोजीशन को ट्रू कॉल करेगा, तो उस कंडीशन में आपके पीएनपी सेंसर से 24 वोल्ट आएगा ही आएगा. अंडरस्टूड और नॉट? आर यू अलाइंड क्लास? यस और नो में रिस्पॉन्ड करिए. आर यू अलाइंड टू दैट नाउ? गुड गुड. हमें ओके, सो हम 3 वायर सेंसर को भी देख ही लेते हैं. आई थिंक दिस वन इज discrete.
Do you want to learn how to hack into systems as an ethical hacker? Check this. I've used this.
In this diagram, like an inductive proximity sensor to a PLC input card. You'll also learn what a 3-wire discrete sensor is and recognize some of the common types of 3-wire discrete sensors. start this video, I have a favor to ask you real Parse fans here on YouTube. If you love our videos, we would love you to go ahead and like this video. This is a great motivator for us to produce free, valuable content for you. That would also help others to more easily find our videos on YouTube. Also, be sure to subscribe to our YouTube channel if you haven't already done so. Now, let's get into the video. Process to the PLC program. DC sensors can be used to indicate the state of a device or a process to the PLC program. Knowing these input states can allow the PLC program to make decisions, such as when to start or stop a conveyor motor. In this diagram, the programmable logic controller, or PLC, is running a ladder logic program. The inductive proximity switch is connected to a PLC input card, and the logic program is written to sense the state of the switch. For instance, when a box is placed on a conveyor at the loading position, the proximity switch senses the presence of the box and commands the conveyor motor to start to transport the box to the next inspection station. So, let's see how we can make this important discrete sensor input information available to a PLC program. In order to do this, we need to understand more about these discrete sensors and how they are wired to the PLC. Discrete DC sensors, or discrete direct current sensors, operate in a circuit with a battery or other power source, commonly known as a power supply. A power supply is placed in an electrical circuit to provide power to the connected devices, like proximity switches or a motor. DC power supplies are referred to by their voltage and capacity, indicated by how many amperes they can supply. The more amperes a power supply can deliver, the larger and more expensive they generally are. In DC PLC circuits, the power supply almost always supplies 24 volts DC to the connected devices. In this diagram, a DC circuit is shown, which turns on a motor when a proximity switch senses the presence of a part or an object in a specific location. The common trait of all discrete DC sensors is that they have exactly two operating states, on and off. A discrete DC switch, as in this diagram, is on when an object is in proximity to the switch and its internal contact is closed, forming a complete circuit and allowing the flow of electrons. When the object is moved away from the proximity sensor, its contacts are opened again. The circuit is broken and the flow of electrons stops. The state of the switch is off. Other common examples of discrete DC sensors include many other types of proximity sensors, level switches, pressure switches, and photoelectric sensors. If we want to monitor the state of a proximity sensor in the PLC, we would need to connect the 3 wires of the proximity sensor to a digital input card in the PLC. When the proximity sensor does not sense a part nearby, the PLC would see the input state as off, or a 0. The circuit to and from the PLC input is open or not energized. When a part moves in front of the proximity sensor, the PLC input senses the change in state and transmits this data through a communication channel to the processor memory, or data table. When the proximity sensor senses a part nearby, the circuit to and from the PLC input is closed or energized. We could then write a PLC program, which resides in the memory of the PLC, to take some action, like starting a conveyor motor when a part is near the proximity sensor. Wiring a discrete DC sensor to a PLC input card is easy and straightforward. In this video, we will consider only devices that have 3 wires that need to be connected to the PLC digital input card. An example, an inductive proximity switch, is shown here. In a separate video, we will consider some simpler 2-wire devices. For most PLCs, the input cards must match the type of circuit that will be employed to interface the device to the PLC. For example, a discrete DC device must be wired to a discrete DC input card. A discrete AC device would require a discrete AC input card. In this video, we will consider only DC devices. In order to connect a 3-wire discrete DC device to the PLC, we will need to identify whether the device is an NPN or a PNP type. NPN and PNP are 2 types of bipolar transistors, which are simply solid-state switches. You should always check the manufacturer's data sheet for the device you are going to connect to the PLC to make sure you know its configuration. For now, just remember the NPN switches are referred to as syncing, and PNP switches are referred to as sourcing. Note that each of these sensors has 3 wires. Wire 3, the black wire, is always connected to the load, which is the terminal for an input on a PLC digital input card. In this simplified diagram of an inductive switch, there are 3 wires, 1 brown wire, 1 blue wire, and 1 black wire. The standard convention is that the brown wire is connected to the positive side of the power supply, plus 24 volts DC, and the blue wire is connected to the DC common terminal of the power supply. This is the negative terminal that is present on the power supply. The black wire is the output, or load wire, of the sensor. It gets connected to the PLC input terminal. Earlier, we said an NPN sensor was referred to as a syncing switch. This means that the load, which is the PLC input, is wired as shown in this diagram. Notice that plus 24 volts DC is wired to the PLC module's common terminal. In other words, when the switch changes state, it syncs the load to common or ground.
क्लास इसका स्क्रीनशॉट ले लो आप, अगर आप लैपटॉप पे हो तो भी, और अगर आप मोबाइल पे हो तो भी. ये आपके बहुत सारे कंफ्यूजन को दूर कर देगा ये डायग्राम. आर यू गेटिंग इट? क्लास ओके. मैं ये स्क्रीनशॉट लेने को क्यों कह रहा हूँ, आपको समझ में आ जाएगा. अभी तक whatever we have learned is there are 2 type of sensors, one is PNP and one is NPN. Now I already told you that if there is PNP sensor, then from collector, whenever there will be an actuation, a current of 24 volt will be passing, so it is sourcing. Okay. And for NPN sensor, what will happen, that load wire will be of, here in this case they are referring it to minus 24 volt. In our case generally we refer it as 0 volt. Okay. Okay, understood? Okay, now let us go ahead. Just take the screenshot of this.
For many PLC manufacturers, connection of NPN sensors requires a specific model number for the digital input card. Because NPN sensors are syncing, they require a sourcing type PLC input card.
This is also a very important information for you, that if there is a syncing type of switch, NPN type of, then you will have a sourcing type of sourcing type of PLC. Okay, so if there is a PNP type of switch sensor available with you, then what kind of PLC you are going to get? Okay, it is always going to be opposite. Okay, so my question is, if you have a PNP sensor with you, that means what kind of sensor it is? Sourcing or syncing? Sourcing. Okay, and for sourcing kind of sensor, the kind of PLC to which it has to be connected will be syncing. Okay, so if it is a PNP sensor, then your PLC will be syncing PLC, and if it is a NPN sensor, then your PLC will be sourcing, and vice versa. Okay, this is also a very important thing for you to understand. Let us understand that why it is.
A PNP sensor is referred to as a sourcing switch. And this means that the load, which is the PLC input, is wired as shown in this diagram. Notice that the blue common wire is connected to the PLC module's common terminal. In other words, when the switch changes state, its sources or supplies plus 20.
Now you can see that it is connected to the common. So this blue color wire was 0 volt or minus 24 volt. And you can just let me just take a screenshot of this and tell you in the PPT itself. So now you can see, you can just imagine that what is a PLC? PLC completes a certain circuit. There is a resistor, which you can see there is a resistor of what we say, which is an optical encoder which transforms 24 volt into 5 volt and send it to the logic. Okay, we will get into this, but it is very important for you to understand this also. Okay, so now you can see, you can just assume that there is a resistor in between this circuit. Okay, so this circuit has to be completed. Therefore, if PNP sensor is sourcing, so you can see black wire was your plus 24 volt. If this is sourcing, then it will be connected to syncing PLC. This PLC is syncing so that the circuit is complete. Okay, again I am going to repeat it. Kindly have a look into it. This is an external battery supply. This is your plus 24 volt. This is your minus 24 volt, and this is your load. Okay, so when there will be this is a proximity switch. When a object will be in proximity of the switch, it will supply 24 volt. Okay, it will supply 24 volt, and that 24 volt will be passing through this. Okay, in contrary to that, if it would have been an NPN switch, during the proximity, this terminal would have been connected with brown wire. This should have been plus 24. This circuit has been completed, but this should not have been connected through BJT connection. Okay. In NPN type of switch, what was collector? What was collector? It was a syncing device. So it will sync only when there is an object near to it. Okay. So are you aligned to it right now? Ritik, are you asking about in PLC or outside PLC?
So means if we get the input voltage of 24 volts, why don't we use a voltage regulator directly to convert it to 5 volts?
Yes, a very good question, because voltage regulator will apply a varying load of 5 volt. It will never give us, it will never ensure us that that particular volt is of 5 volt only. So if there is a fluctuation, your entire PLC is going to be damaged. The main important motive is to safeguard or to provide the security to the PLC, and therefore we have a optocoupler type of thing. Even if there is a power surge and high voltage is going, so the, you can say, power is transformed through optocoupler, through light. Okay, so LED is not going to give a surge voltage, whereas in voltage regulator you cannot ensure, yes they are very much robust, but you cannot ensure that it is always going to be 5. So safety is a very huge parameter here. That is why we use a separate optocoupler type of technology here. Okay, Ritik, is your question resolved? If you have any other doubt, you can get back to me. I will.
No, sir, it's resolved.
Okay. So thank you for asking these kind of questions. These kind of questions also increase your aspect that why voltage regulator, why we are using a separate optocoupler in a PLC. We already talked about the ruggedness and the robustness of PLC, and we don't want that PLC to be damaged. Okay, so if we are using a voltage regulator, which is just a device which regulates the voltage, we cannot ensure it because it is directly converting a type of electrical energy into electrical energy. Okay, whereas here in this case, an optocoupler is just a source of information that is regulating 5 volts into the PLC. Okay.
4 volts DC to the PLC input. For many PLC manufacturers, connection of PNP sensors requires a specific model number for the digital input card. Because PNP sensors are sourcing, they require a syncing type PLC input card. Because NPN sensors sync voltage and PNP sensors source voltage to the PLC input, NPN and PNP sensors should never be mixed on a PLC input card. Doing so can lead to an unsafe condition. In this diagram, an NPN and a PNP sensor are both connected to the same PLC input card. Note that the common terminal has a brown wire from the NPN sensor, with plus 24 volts DC connected to a blue wire from the PNP sensor, which would short the power supply to ground. Now, let's see how 3-wire discrete DC sensors are connected to actual PLC I/O cards. This is a schematic of one model of Siemens SM321 digital input card, part number 6E7B H01-7BH01-OABO. It is a 16-channel, 24-volt DC digital input card that is very popular in Siemens PC S7 and S7 300 PLC systems. This digital input card wiring scheme is similar to most digital input cards used in the process industries. The SM321-7BH01 has 20 screw terminals to which the digital inputs are connected. As we saw previously, for 3-wire discrete DC sensors, each digital input channel requires the connection of 3 wires. The SM321 card is constructed so as to accept only PNP type sensors in a 3-wire configuration. Use of NPN sensors would require a different model of I/O card. The SM321 card
Up till now, it is only saying that you can't intermix an NPN sensor with a PNP sensor for a same I/O module. Okay, so for an system which is consisting of an NPN sensor, you will need a PLC which is, if there is an NPN sensor, the PLC will be, to integrate a NPN sensor, PLC will be sourcing. Yes, correct. The PLC will be sourcing. Okay. Only 2 answers. Rest are not getting this question or what? Again, I need to ask one by one. You got this right? मैं कोई कॉन्सेप्ट स्टार्ट कर रहा हूं तो मैं उसको छोड़ूंगा नहीं, फिर मैं एक एक से पूछना शुरू कर दूंगा भले ही कितना भी टाइम लगे. आई नीड आंसर्स क्योंकि ये बहुत छोटी छोटी चीजें हैं जो आपको पता होनी चाहिए. ठीक है, ओके. दे माइट लुक इजी फॉर यू कि ठीक है ये तो हो गया कि हाँ कि अगर आपका पीएनपी सेंसर है तो मेरा पीएलसी जो है वो सिंकिंग होना चाहिए, अगर एनपीएन सेंसर है तो सोर्सिंग होना चाहिए. बट जब एक्चुअल कंडीशन में आप वायरिंग चेक करने जाओगे तब आपको यही चीज परेशान कर रही होगी. अच्छा ये पीएनपी सेंसर था, अच्छा यहाँ पे एनपीएन सेंसर है, अच्छा ये वायरिंग ऐसे होगी. सपोज इफ यू आर अ प्रोजेक्ट इंजीनियर, ओके, आप प्रोजेक्ट इंजीनियर बनने जा रहे हो तो आपको पीएलसी लगाने तो पड़ेंगे ना हर प्रोसेस पे, वायरिंग तो करनी पड़ेगी ना उसकी, वायरिंग डायग्राम होगा, वायरिंग डायग्राम को देख करके आप लगाओगे, बट एक जनरल सेंस तो आपको आ जाएगा ना। इसके लिए आपको आंसर करना बहुत ज्यादा जरूरी है। आप आंसर करते हैं तो आपको ऐसा नहीं है कि हाँ बहुत इजी चीज है, बट जितना ज्यादा आप इसको कंटिन्यूएशन में लाएंगे ना, ये आपको बहुत ज्यादा हेल्प करेगा, क्योंकि ये चीजें फिर आपके लिए बहुत ज्यादा इजी हो जाएंगी जब आप फैक्ट्री पे जाओगे आप, ठीक है ना। तब आप इजीली कह सकते हो अच्छा इसमें ये है, ये ऐसा इशू है, चलो ठीक है इसको ये भी कर सकते हैं वो भी कर सकते हैं। आपका स्पैन जितना ज्यादा बढ़ता जाएगा इस नॉलेज को लेकर के, छोटी छोटी चीजों को लेकर के, उतना ही आपका कंफर्ट लेवल बढ़ेगा, उतना ही ज्यादा आपकी एम्प्लॉयबिलिटी बढ़ेगी, उतना ही आपका कंफर्ट जोन भी बढ़ेगा, ठीक है ना। ये बहुत छोटी छोटी चीजें हैं, कहने को तो ये गूगल पे भी मिल जाएंगी, बट राइट काइंड ऑफ क्वेश्चन एट राइट काइंड ऑफ टाइम इज वेरी इंपॉर्टेंट, ठीक है ना। आज आप अगर 3 वायर का सिस्टम को पढ़ रहे हो, ठीक है ना, कि पीएनपी है या एनपीएन है, आपने एकेडमिक्स में तो बहुत ज्यादा एनपीएन सेंसर पढ़ा है, पीएनपी सेंसर पढ़ा है, बट जब आप लिंक करने जाओगे तो पूरी थ्योरी को दोबारा थोड़ा पढ़ोगे, ठीक है ना। तब आपको केवल एक ही चीज काम याद आनी है, अगर पीएनपी सेंसर है तो उसका कलेक्टर से करंट पास हो रहा होगा जब कोई एक्साइटेशन होगा उस पर, यानी कि वो सोर्सिंग है, यानी कि उसको किससे कनेक्ट करना है हमको, सिंकिंग से, ठीक है ना। तो आपको वो कंफर्ट जोन मिलेगा, आपको पता भी नहीं चलेगा आप कितने कंफर्ट जोन में आ गए हो और कितना आपको ये हेल्पफुल होगा, ठीक है ना। बट ट्रस्ट मी, आप इसको एक कागज पे लिख के रख लो, दिस इज गोइंग टू हेल्प यू फॉर अ वेरी वेरी लॉन्ग टाइम, ओके। So please answer these questions.
Requires 24 volts DC power to perform several functions. First, the card itself requires power to light the status LEDs, perform diagnostics, and to communicate the card's input statuses back to the PLC. Power to the card is supplied by a 24 volt DC power supply, connected to terminals 1 and 20. Internally, inside the SM3421 card, this same 24 volt DC power is connected to terminals 10 and 11. The power at terminal 10 supplies power for the top group of 8 digital input.
This so we have covered.
For a PNP device,
Now you can
terminal
just see
3 to terminal B, and so on.
this much we had covered on the single 2-wire sensor, but now he is trying to tell us about the PNP sensor integration.
Now, let's connect a PNP inductive proximity switch from the previous example to the SM321 card. The 8 marshalling terminals A through H are wired to channels 0 through 7 and are the load terminals in our discrete circuits. 24 volts DC will be obtained from terminal 10. Terminal 20 is connected to the power supply DC common. For a PNP device, care must be taken to connect the brown wire to the 24 volt DC terminal and the black wire to the PLC input channel terminal. If we connect the proximity switch to PLC input channel 3, then the black wire will land on terminal A. Finally, the blue wire will be connected to the power supply DC common, terminal 20. When the proximity switch senses an object nearby, the state of the switch will change, and the input channel to which the proximity switch is wired will indicate an on state. Both the electronics in the switch and the PLC card are powered by the same 24 volt DC power supply. To review, we have learned that there are many types of discrete 3-wire DC sensors that can be wired to a PLC input. Some 3-wire devices are NPN, or sinking sensors, and some are PNP, or sourcing sensors. The difference is in how the device operates when the switch actuates. NPN switches sync DC common to the black wire where the switch is activated. PNP switches source 24 volts DC to the black wire when the switch is activated. Remember, in both cases, the black wire is connected to the PLC input channel terminal. For most 3-wire devices, there's typically one brown wire, one blue wire, and one black wire. A schematic of your specific DC digital PLC input card is required to determine how your specific device should be wired. For a 3-wire PNP discrete input device, the brown wire will be connected to 24 volts DC. The blue wire will be connected to DC common, and the black wire will be connected to the PLC digital input channel terminal. Make sure that you head over to
So what I wanted to convey to all of you was that when I was going through answers of um yours which you have given me on WhatsApp, most of you have not provided any kind of energy to sensor, but now we have seen that yes, an outside 24 volt is required for few sensors, and for magnetic read sensor, which was a 3-wire sensor, it is required. Okay, now let us just look at the pneumatic diagram, or you can say at the component level. This one. Okay, so for most of you, what you have done is that you have taken a what mistake most of you have done is, I have not given electrical energy. I had given, but I think that it might would have been erased. So most of you have answered like this, that there is a sensor and there will be an information flow here. There will not be an okay, so this will be a dashed line. This is going to be a dashed line. Okay, so this is a information flow to the sensor. Okay, this is an information flow, and external electrical energy supply will be provided to sensor. Okay, an external energy supply will be provided to the sensor. Okay, so now let us just okay. Make a good diagram out of it. Let us take a very clear solution. Let us move towards that. And okay, so now let us continue with what the exact solution might be. We have a cylinder. Okay, we have a cylinder. And for cylinder, what we are getting pneumatic energy into the cylinder. Okay, we are getting a pneumatic energy into the cylinder. Okay, then we have a valve, and that pneumatic energy is being passed through a solenoid valve only, as we have seen that air supply will be going from a compressor to solenoid valve to your cylinder. Okay, so the energy flow will be like, this is your cylinder, there might be a solenoid valve. Okay, there will be a solenoid valve here, shape fill, let us say no fill, and you will have an energy for this also. This will be your This will be your pneumatic energy. So from your solenoid valve, it will go to your cylinder. Okay. Then you have a sensor. Say this is your sensor. Okay. This is your cylinder. Insert text box. This is your cylinder. Okay. These are your two sensors, which are your magnetic reed switch. So I am using MRS, which is your magnetic reed switch. This is your solenoid. And this is your PLC. What you missed was, most of you were correct, but what you missed was two things. This is your magnetic reed switch. So my question to you all is that these two lines my question to you is that these two lines, will these line be dotted or will these line will be solid? So is it a information flow or is it a energy flow? Ritik, you are saying one will be solid, one will be dotted. Why? Can you unmute your mic and answer this question?
Sir, maybe I'm a little confused for that.
Yeah. See. So again, let us look at the process. We have ample amount of time. We are only here to understand the system. No need to panic that we are taking so much time on this thing. Everyone takes that much amount of time to understand this thing. But you are lucky that you are getting this experience at your home during academics. Okay. So suppose if you need to understand these things when there is a urgency in industry, you might be in trouble. So you have ample amount of time here. Just look at this. What is cylinder giving to these sensors? There is just a piston inside which has a magnet to it, and when magnet comes, okay, it just gives a signal that yes, a magnet is in the proximity of it. Okay, it is not an dedicated energy that has been given to drive it. It just gives a signal or information. Yes, piston position is here or piston position is here. Okay, so yes, Ankush, you are very correct. Varun Pathak, you are very correct. Aprajita also, you are very correct. Adarsh, Kalpana, Abhay, Sahil, you all are correct. Yes. Okay, so that is the information that has been given. Okay, now just tell me. So these line will be dotted. These line will be dotted. This is your assignment also. If you are drawing it side by side, you are completing your assignment also and you are saving your time. Okay, so just follow what I am doing. Okay, so I will ask you to draw individual energy flow diagram and then one integrated energy flow diagram. Okay, we are just completing for cylinder only at this point of time. Okay, now this solenoid might be getting some energy from compressor. Let us take this is a compressor. Okay, this is your cylinder. Okay, now this is not your you can say that this is your
सर ये डीसी भी होना चाहिए था.
yeah, this is your DCB. This is not solenoid valve, this is your DCB. Okay, this is your directional control valve, okay, which gets a form of energy. It transforms that energy to cylinder. Okay, but this DCV gets information, or you can say get actuation from a particular system, which we call it as a solenoid. Okay, now this solenoid will get something from PLC. Now tell me whether this line will be dotted or whether this line will be solid.
Dotted.
This line will be dotted. Why it will be dotted? Because PLC will give a signal to the solenoid to push the DCB. Okay, to push the DCB. But solenoid, you all know what solenoid it is. It gets a signal and it transforms it into a electrical energy. Okay, so it will get an electrical source of energy from outside also. This will be a solid line and this will be electrical energy passed to it, and solenoid will give what to DCV? Information or energy? Will that be energy or information? Class?
Information.
Information. Is it correct? Are you getting it? Okay, so now you can see that this is completed. This was the kind of answer that most of you have given, and through this, but of course a line was there, a dotted line, and this sensor was giving a signal to your PLC. But we all learned a very new thing, that this is a magnetic reed switch. It will get information through proximity of a magnetic switch. It will give a voltage output if it is a PNP sensor, or it will give a information about its proximity. Okay, about its proximity, but it will be supplied by an external power. This was the thing that most of you have missed. Okay, so this electrical energy, now you all understood that where you were lacking, you all have almost made the same type of diagram, but what you were not able to collect was that for sensor, you are going to get a separate source of electrical energy. Okay, am I correct? So now, are we all aligned to the concept till pneumatic sensor? Kindly confirm on the chat box, then we will take a break. आंसर सबके मिल जाएंगे तो मैं ब्रेक दे दूंगा, नहीं मिलेगा तो नहीं दूंगा. हाँ ठीक है, वेरी गुड. Okay, so it is 3:47. We will meet at 4:05. Okay, we will meet at 4:05.